Uh, so now we'll welcome Xiong from Intel for his session on OFI 2.0 update. Xiong works for Intel. He has a rich experience in various layers of high-performance communication software stack, including middleware libraries and kernel drivers. Lately, he had a DMA buff-based GPU RDMA to support the Linux RDMA subsystem. He's also the Open Fabrics Alliance workgroup chair for the OFI and OFI libfabrics maintainer. Take it away.
Hi, everyone. Let me start sharing my slides. Okay, how to...
Perfect.
Okay, great. So I'm Jianxin. I'm glad to have an opportunity here to present the latest update of Open Fabric interface development that we call the 2.0. So today's talk will be mainly consist of 3 parts. In beginning, I will give an introduction of the Open Fabric interface and the history and some of the basic concept. And then I will give some a summary of proposed changes to the Open Fabric interface 2.0, and also some of the maybe get a little bit of detail into each of the proposals. Finally, a timeline will be presented about what we're going to expect in the next couple of months, and maybe in this year, for what change we are expect to get into Open OFI 2.0. So to start with, I will give some overview for the Open Fabric interface. We usually just say OFI, and another name is libfabric. That's the project hosted in GitHub, and also the library distributed by the OFI release. So in later context, the libfabric and the OFI, I'm going to use the interchangeably. So they basically mean the same thing. So OFI, yeah, there's in previous talk, there was a question about what is OFI, or maybe what is libfabric. libfabric is an open source, low-level communication library designed to be optimized for the application and for the network. So usually the network and application, the semantics or this, some of the times they can have a very good match, but sometimes there are some the interface provided by the network or the functionality provided network does not match perfectly or exactly as what application usually want, application how to use those functionality. So what OFI trying to provide is a level between. So at the top level, it defines API based on the application needs. So some application they may need a very simple communication, send and receive something. Some application they want more advanced features, such as they want tag matching support. Some may need RMA support, or some may want to have the atomic support, and those varies based on the application. So OFI defined the interface that provided the flexibility. I mean, every different functionality, they are grouped as a separate functional group. Here we say, look at the right-hand side of this picture. So OFI define we have a message interface that's a regular message passing, send and receive. And there's a tagged interface that's for tagged messaging. So that's for the MPI or other, maybe some middleware also require this kind of semantics. And then we define the RMA interface for the one-sided operation, read, write, and atomic support, and a collective interface. So in order to do those, OFI also need to provide in some additional functionality groups. For example, the completion semantics. So we define the completion queue-based completion. That basically, yeah, is basically when a completion is done, is posted in the queue, and the application can pull the queue to see if the work has been done. And there is another simplified, maybe not simplified, it's more toward to lower overhead interface. If the hardware can support this, is the counter-based completion. So basically, you set up a counter, and then when the completion only increase the counter without generating an entry in the queue. So that is a generally lower overhead. Some application, especially say those shared memory, the PCAS applications, they usually prefer using counter instead of a completion queue. And also we have the event queue that to capture asynchronous event generated by the system. For example, when you set up the connection, you want to know if the connection is established or encounters any error. And the other component of the API is the communication setup. So we have two mechanisms. One is the connection manager. So you could manually set up the connection if the endpoint requires a connection setup. So basically, that's the going through similar to what you set up a TCP connection. You have a listen, have a connect, and the server side can do accept, and finally both ends will get into a connection, the connected status, and you can start a communication. The other one is connectless connection setup. Basically, you don't need to set up a connection. Instead, you just use an abstract address for the destination and to representing the target of the communication. You want to send a message to the other side, you just use the address of that endpoint, and the library will handle this internally to whatever needed to get the message to the destination. And the other main part of the API is the discovery, also including the creating all those system objects that needed for the communication. The discovery is actually one big feature of OFI. So it allows kind of flexibility. So because the underlying network may not support all the features defined by OFI, and the discovery process allows you to find out what the provider is capable of, and if all those features are required by the application is supported by the provider. So during the process, only those providers that's supported all the requirement will be returned, and the application say you can write a same application, and it can run on different environment based on the runtime discovery mechanism. So as I said, I mean, there's on the picture, the lower level is about the implementation. So I'm implementing this API. We have some core code functionality that's For example, the discovery path, I mean, the general data structure, all those how the API is get called into the lower level, those are in the core. And we also define some utility function that is most common abstraction that can be used both by the core and the providers. And the other important part is the provider part. So for each different hardware, we have a provider to implement the API, and the API call is going indirectly through some internal functional pointers going to the provider. So that means the API and the implementation are kind of separated, and this allows the provider have flexibility to do whatever it is needed to implement the API. So by doing this, the main feature of the Leaf Fabric is we could provide many of those low-level optimizations available from the hardware, no, from the network stack to the application, such as we can have this always bypassing, zero copy, and trying to minimize the memory footprint. All those features can expose to the API, to the application, and also without requiring like all the network infrastructure to actually supporting the same capability. So it has been some time since Leaf Fabric was started. So the first, I look at the history of the code. The first commit was made in 2013. That was more than 10 years ago. And the first official release for Leaf Fabric was in 2016. And after that, there are about 55 released in total, including some feature release and some bug fix releases. The latest release, 1.20, was released last month. And there are a lot of have been changed since the 1.0 release. For example, this list of some features has been added since the very early release. Like we got now support authorization keys, we support a multicast, and introducing the more features like the string address. And actually the most important one is the supporting the HMAN. It's called a heterogeneous memory. That is very important, especially today. We are seeing more and more usage of GPU and other accelerators with Leaf Fabric. From the provider side, we also see a great expansion of the providers. The initial release, we only have 4 providers. Some are like example, but some are actually running on the hardware available at that time. But now today, the number of providers are almost 4 times the providers compared with the initial. We are running on a various different hardware from different companies. And at the middleware side, we now have support from many variation of MPI, including Intel MPI, Open MPI, MPIC, and also some PGAS program models like Xiong, GasNet, and also other models like Charm++, and a collective library like 1CCL and Nico, and a distributed distributed file system like a Deos. So we have seen success in the growth of the fabric itself, but also at the same time, we have been seeing some issues with the existing API definition and the implementation. Mostly, those are related to some complexity when using the lib fabric. Some of the API definition, some options are become a little bit more than needed. Some options are complicated to use, so it presented a difficulty for both the user and the provider development. So here is the opportunity. So we may want to be able to do some simplification. So far, we have been able to maintain this backward compatibility both for API and ABI during all the 1.x releases. So for this backward compatibility here, we means for API backward compatibility, that means existing application, we can compile the source code against the newest release head and the library and run successfully. And for ABI backward compatibility, so the existing binary should be able to run with the newer release without issue. So those are the possible because when we do API change, we always do appending, so adding thing to the end of the data structure or adding new API calls. We never remove something or reorder the field. And for API compatibility, so we that's also affecting the API compatibility. So we use some stubs to provide in an API compatibility layer. So that at runtime, it will check the API version required and will use the right stub. Even the underlying implementation is a newer one and providing something different. So I said before, some of the issues we feel about the current lib fabric is something part of maybe to overcomplicate it. Have some we want to have something simplified. Those things would break either API or ABI compatibility. So we need to bump the version to 2.0. So beside the simplification, this version bumping can provide, we can also have some opportunity to optimize the interface. So to be able to allow more efficient provider implementation by removing some requirement or maybe some mechanism that is introducing overhead but not providing much real performance benefit. At the same time, we will also introduce some new API. Those new API will not break anything, so that's at the same time. And maybe we also redefine some existing API to add in some semantics to the API. Those may or may not break the API compatibility. With the one goal to move into this new version is we still want to maintain some kind of API compatibility. That means if something is not removed, it's the same. If something is defined as the same as the 1.x series, that part should still be API compatible. So that means when we are modifying the data structure, we are still going to mostly do appending. If we're removing something, we probably will keep the field there, just removing the definition from the API. So you are not going to use that one, but the space still are reserved. Here is the summary of the proposed changes in LibFabric 2.0. I classified them into 3 categories. So simplification, optimization, and new features. So I will give a brief go through of all those changes. And for some of them, if we have time, I will go to a little bit detail. For simplification side, we have proposal, for example, to remove the asynchronous address vector insertion option, remove the AV map support, remove a few threading models, and consolidate the progress into a single progress model. I mean, previously we have the separate for the control and the data, and we want to consolidate into a single one. Remove the completion order attribute. So that means all the completions we won't have it, don't guarantee any order anymore. Remove some field that has been deprecated, and remove the weight set and the pole set concept, and remove some mutex condition weight object type, and remove some deprecated MR mode bits, and also remove asynchronous MR registration. On the optimization side, one major part is we're trying to trying to modify this binding way between the endpoint and the completion queue. So want to restrict the endpoint to a single completion queue, so that will provide the opportunity for optimization in the provider for making progress. And we want to have some new level for the log functions, and redefine one of the parameter for future expansion. And we want to have some flexibility in the capability for directed receive, and as well as the HMAN capabilities and some sizes related to the different messaging functionality. For the new feature side, we want to have a new fabric core to make it consistent with the other API calls, and also ability to pass in some information needed for some provider. And in addition, we want to do some have some new atomic types and atomic ops especially for the AI application. And in the end, we have some new feature for about the peer group and the tag format. So I think based on this time left, I think I will going to start with some of the new features, and going back to the simpler changes if we have enough time. So one of the major changes we want to propose through 2.0 is a concept called a peer group. So the peer group is basically something similar to what people see in for example, in MPI, the concept about the communicator. So in current libfabric API, we don't have the communicator or group concept. So all the communication you happens to between, you say you just give the remote address and then you send a message to that, and that there's is a single word. And when implementing middleware like MPI, this group concept is usually mapped into a certain part of the tag. So consume some tag base as the communicate ID or group ID. That's sometimes this creating a stress in the tag space. The proposal here is we add a new concept called a peer group, and that information as a part of the address vector. So right now the address vector is a 64-bit integer. But if we, in most case, if we implement the address vector as a table, that 64-bit is plenty, is much more than enough. I mean, it's more than, and so we can reserve part of those address vector and use that as a group ID to identify the communication group. And this group ID is set by user. So basically, user based on their exact requirement. For example, if the MPI, they can just using the communicate ID, setting that into as the group address. So the new API will define a function specifically for setting the group address into the FI address. So this support is going to be optional. So provider will indicating the available peer group support by setting the max group ID to a non-zero number, and that will indicating how many groups are supported by the provider. And the application is supposed to use the FI get info to discover this support and do this accordingly. The benefit of this proposal is to free up the tag bits. Otherwise, those are going to be used by the communicator ID. Also, it has the benefit to increase the effectiveness of tag hashing. So because the communicate ID when is part of the tag, it make it is sometimes the provider may not understand what those bits are. When they perform some hashing algorithm on the tag for improved matching performance, those bits could negatively impact the hashing algorithm, creating a lot of conflicts. I mean, you should be able to if I have a lot of common bits there, those are just you're always hashing to the same place. So that is the one of the major changes. And the other major changes is the new tag format. So the tag format is a way in the current API to providing some way to dividing the tag into subfields. Yeah, also those fields are just the provider can handle those fields differently. Yeah, it's also related to the how you may like hashing the tags. Kind of the behavior is basically you can define the format as alternative 0 and 1s. For example, if we define this as a zero, this value shown on the picture for FFFF0000, I mean, this definition is defining 4 fields. Each of them are 16 bits. So the provider will know, okay, these are there are 4 fields. So each field maybe have some meaning, but the provider don't really know what it means. It can do some optimization based on this definition, but it's really hard to know what the application really mean for each of the fields. So the proposed change here is we could reuse some of the tag format bits for some well-known usage model of the tags. The kind of proposal we have defined the 3 different models. The first one is a FI tag base. That means all the tag are interpreted as individual bits. So that's exactly what we are doing right today. And this tag base can allow to be matching either exactly or with arbitrary way for wildcarding by setting the ignore bits based on the application needs. This is the most common use, and it's compatible with what we have today. And the second model is the tag MPI. So this is trying to follow what MPI use tags. Since we already have this communicator ID move that into the peer group. So then what MPI needed today is only 32-bit tag, and another 32-bit can be used for many different purpose for we call it the payload ID. And this, for example, the payload ID can be the ID to distinguish between different operations, like the send and receive could be for a collective implementation, and also maybe different collective information. So this one is for the all-to-all. The other one is for broadcast, such as this. So by using this model, the application is required to use the predefined function to set the tag. So by combining the tag and the MPI tag and the payload ID into a 64-bit tag, and the ignore bits, you are required to use the predefined one, either ignore tag or ignore payload, or ignore both. So you cannot arbitrarily set the ignore bits, and the provider know exactly this part is tag, the other part is payload, and they can do optimization accordingly. Because basically most of the time for MPI, this tag is the tag is probably the major part for the wide carding to do the matching, but the payload, the majority of the time they are doing exact matching. So the optimization can be done there.
Jim, we need to wrap up.
Yeah, so just a quick way about this tag CCL, and I'm going to wrap up quickly. The CCL tag is this is this is the model for the collective library, and so in this case, there's never been wildcard. Every tag matching, every tag is exact match, and they never reuse the tag. So every communication using a different tag, So it's more like you can consider it something like you are doing something like you have it's similar to what a RMA operation with a key is doing, and this is set directly. I mean, if you're using this model, the provider can be even more simplified because you don't need to search through the different tags. It's just a single mapping. So let's go back to this table. I think I should go to the last slide. Yeah, for the rest of those changes, people can look at those slides. I mean, the slides are going to be available on the website. So there's a timeline for this one. Because the amount of changes and the scope of changes for the 2.0, we are going to have a longer release cycle compared with the regular like 3 release a year. So tentative plans, we plan to have this 2.0 alpha out in July this year, and we have going to have a beta release in September, and the general availability will be November 2020. And the alpha release, we mostly going to get the proposed feature in. Some of them are still in discussion, but we resolve those distribute discussion and get the most feature in. And in the beta release, we going to be feature complete and have the validated, and the GA, we are majorly fixing bugs discovered in the beta. So at the same time, we will continue release some of the some in this 1.x release series. So we will create a new branch for the 1.x release, and using the main branch for the 2.0 development. And those time frame, yeah. So at least we are expecting like 1.22 and 1.23 this year, in addition to the 2.0 releases.
Okay. Well, we are a little over time, but I'd like to invite questions. Really good talk. Very, very detailed. If there are no questions, you can reach out to Jing, and you can also view the slides, and the presentation will be available as a video in a few days. And thank you very much.
Okay, thank you.